Hello, today's video is going to be about graphing reciprocal functions, which is part of rational expressions. And we remember that rational expressions are fractions, basically. So we're going to look at what the reciprocal parent function is. And that is just f of x equals 1 over x. And you can remember this by thinking about the reciprocal of a fraction is when you flip it over. So like the reciprocal of x is 1 over x. So that's why this is the parent function for this. So the type of graph that this makes, let's actually draw the graph first. The graph for this function is kind of odd looking. This is what it looks like, and the reason that it looks like this is because you can't divide by 0. That's what affects this. So if you were to plug in x equals 0, you would have 1 divided by 0, and you can't do that in math. It's not allowed. So, and if you were to put 0 in for y, so if we had 0 equals 1 over x, then we would have x times 0 to get it. We would have to multiply both sides by x. So then we would get 0 equals 1, and that's not true. So you can't have y equals 0 or x equals 0 for this. This kind of graph is called a hyperbola. Oops. Okay, so I said that kind of silly. The right way to say it is hyperbola. Some people call it a hyperbola, but that's not right. It's a hyperbola. But anyway, so what we want to look at is that the domain can be anything except x equals 0. So our domain, we're just going to say, is x not equal to 0, because that's the only value that it's not allowed to be. Our range is going to be y is not equal to 0, because that's the only number that y is not allowed to be. Now, what in the world is an asymptote? An asymptote is a line that the graph will never, ever, ever touch. So it gets really, really close, but it doesn't touch it. And in our case, that's going to be the y-axis. Yeah, I'm going to have to move that one. Boop, boop, boop. And the x-axis. All right, so our graph is going to get so close to the x and y-axis, but it's never going to touch it. So as an example, let's say that we plugged in x equals 999,999. Okay, that would mean that f of x equals 1 divided by 999,999. And even though that is a teeny tiny number, it's not 0. And it never will be 0. So that's why it will not touch those lines. And those lines are called asymptotes. And a vertical asymptote is a vertical line that the graph will never touch. So in our case, that is x equals 0. And the horizontal asymptote is the horizontal line that it will never ever touch, which is y equals 0. And if you notice, these are exact opposites of each other. So since the domain cannot be x equals 0, the asymptote has to be x equals 0. And the same for the range and the horizontal asymptote. So what we want to look at now is how that can change. So we looked at the parent function, we looked at its properties. It was fairly straightforward. It's different, it's unique, but it's not really hard. You just need to memorize it. But let's look at how that function can change. Standard form of a reciprocal function, sorry, I lost my train of thought there, is f of x equals a over x minus h plus k. And if you remember other functions that we've looked at, we've had h's and k's and a's before, and they always mean the same thing. So h is the horizontal shift. And in pretty much any form, that's always the way it is. And positive makes it shift left, and negative makes it shift right. And this is the opposite of what we would normally think, because that is a subtraction sign. So that changes the sign of h whenever you plug it in. All right, k is the vertical shift. And positive shifts up and negative shifts down. And if a is negative, the function is reflected across the x-axis. And these transformations are the same as they always are. You just have to remember where a, h, and k belong. So if the absolute value of a is greater than 1, so that means the plus or minus doesn't matter. We've already taken care of the sign of a in the last section, but if, the number that is a is greater than 1, that represents a vertical stretch. So it's like you grab it at the top and grab it at the bottom and pull. And if the absolute value of a is between 0 and 1, then it represents a vertical compression. Wow, we'll try that again. Okay. The vertical asymptote is always x equals h. So x equals is the form that you have to write it in, and h is the value that you're going to substitute in. The horizontal asymptote is always y equals k. So using that chart that we just made, we are going to look at we're going to try to write some reciprocal functions. So we need to remember that f of x equals, wow, I am killing it with the handwriting today. All right, f of x equals a over x minus h plus k. All right, so the reciprocal parent function is reflected across the x-axis. So let's look at all the things that we're going to have to do. So it's reflected across the x-axis, then translated. I'm going to use different colors to help us focus. Then translated 4 units right and 3 units down. And we want to write an equation to represent the new function. So, reflecting it across the x-axis affects the sign of a. And then, boop, boop, boop. All right, so the parent function is f of x equals 1 over x. So, we're going to change the sign of a, so we know for sure we have f of x equals negative 1. Then we are going to shift it 4 units to the right. That is going to affect h. And if it goes to the right, then the sign in your function needs to be minus. So it's minus 4. And then finally, so that's that. That, guys, because of that. And finally, we have 3 units down. So that's going to be negative 3 minus 3 at the end. And that is from the pink part. So I just kind of want to make sure that you see what all is associated with what as we write these functions. It also asks us to identify the asymptotes. So remember that the asymptotes are h and k. So the vertical asymptote is always x equals something, and it is this value of h. And it's going to be the opposite sign of whatever is in the function because the function starts as subtraction. okay? And then the horizontal asymptote is always y equals, and it's whatever this number is out here. And that one is not the opposite. It keeps the same sign as what's in the function. So this is part of your answer, and this is the other part. So I want you to pause here and try numbers 2 and 3 on your own. All right, once you finish those, check your answers here and kind of look at how did you do. If you didn't get these correct, then I would encourage you to go back and watch the explanation again, or go back and look at the chart again. And if you're still confused, please reach out to me and ask me why, and I will touch base with you. Okay, so next we are going to learn to graph reciprocal functions, and we're going to rely on our calculator quite a bit, but you should be able to sketch these roughly without the calculator, to be honest. So what we want to do here is, first I want you to see how to type it in the calculator. Both of these are correct. Some of the newest calculators will let you type it this way. And you type it that way by hitting the shortcut alpha, then y equals, and then enter. So that's how you get a fraction bar to show up on your calculator. That's just a shortcut to get this right here. Then the other way, the older calculators don't do that. And so you have to use parentheses and division to make sure you type the function in correctly. On Desmos, you will be able to do fractions using their keyboard on the screen. So you'll be able to see exactly what you're doing on Desmos. It's pretty easy to figure out. And then when you hit graph, you're going to see our function here. And I want you to be somewhat accurate with this. It doesn't have to be perfect, but I want you to pay attention to what you're doing. And what I want to see on your graph is I want to see these asymptotes drawn on there. And the way that we're going to do that, so even if we didn't have the graphing calculator part yet, we can see from our function, because we've already learned what it means, we can see what our asymptotes are. So remember, the vertical asymptote is always x equals h. Well, h is supposed to be in the denominator with x, and there's nothing there. So this is going to be x equals 0. And then our horizontal asymptote is always y equals this number out here, k. So -2 is what it is in this case. So our domain and range is always the exact same thing as the asymptote, but not equal to. So y equals -2, not equal to. Okay? That it's always going to be that way for these reciprocal functions. So what I want us to do is I want us to first draw the asymptotes on here. So we're going to draw a line at x equals 0. So that's the y-axis. And we are going to draw a line at y equals -2, which is right here. Then you can go in with your, like from the calculator, we can look back at it to make sure we're doing things right. Let's erase that. And you can see that your curves or your lines should be here. That's really lovely, I know. And here. And it doesn't have to be perfect, but I want it to be darn close, and I do want to see the asymptotes, okay? So you have to have all of this. Oh, that's nice. You have to have this, 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 this. And then I want to see this guy, and I want to see this guy, and then you can rough sketch the other stuff. So I'm going to move through these a little faster, but I do want you to see a couple of things, and most of it is how you type things in the calculator. But this one in particular, we have a negative a value, so I want you to notice what that looks like whenever it's reflected across the x-axis. So in our parent function, the lines are on these sides, but you can see that it's been reflected because of that negative a value. So let's go ahead and go in here. We are going to first do our vertical asymptote, and that is always x equals whatever is with x in the denominator. Again, it's 0. And our horizontal asymptote is always y equals whatever this is. And we don't need the positive. So y equals 1. And then our domain and range are always the opposite of this. So we have x is not equal to 0 and y is not equal to 1. Because the asymptote is what doesn't work, the domain is what does work. And same for the horizontal and the range. So then we will graph our asymptotes. So we start with x equals 0, and then we have y equals 1. And then we go in with our graph, and we draw this in. And so something that I kind of want you to notice is that even though a is, greater than 1, it's actually a 4. Wow, I can't get this right. It changes the graph, but not by as much as you think. And also, look at me, I already messed that up. I didn't pay attention, and I drew them in the wrong quadrants, or in the wrong sections of the graph. So it should have been here and here. Okay, so I'm actually going to draw, or I'm going to graph something else and show you guys a separate picture. Okay, so this is the graph of y equals 1 over x and y equals 4 over x. And you'll notice that they're really not that different. It's hard to tell the difference. So this one out here is the 4 over x graph. And this one in here is the 1 over x. And then they correlate to each other. You know, they're mirrors of each other. Can't use my words. Okay, but the only difference is how far that middle part is. But if you notice out here, they almost look the same, and those numbers are so infinitely tiny that basically every stretch or compression is going to be really, really similar to the parent function. So you need to notice that that's happening, and you should be able to identify that just from looking at the equation, you should be able to know that the function is being stretched or compressed. But just looking at the graph, it's going to be hard to tell, and it's going to be hard to show. So I don't want you to stress too much about that as you draw your graphs. And this last example that I'm going to do with you, I honestly only did to make sure that you know how to type them in the calculator correctly, because you have to have so many parentheses in whenever you do this. So if you can use the shortcut, that's easy enough. But if you can't, look at how this has to happen. So you have to have the fraction as like in parentheses, but then you also have to tell your calculator that the denominator is not just x, okay? Because without parentheses, your calculator would read this as 2 over x plus 4. But you need to make sure that because you have parentheses, it sees it like this. Okay, so anyways, going back to, we might as well finish this one since we've got it pulled up. Our vertical asymptote in this one is going to be x equals -4. And remember that it's the opposite sign of whatever is down there for the for the x equals part. And then our horizontal asymptote is at y equals -7. So that means our domain is x is not equal to -4, and our range is y is not equal to -7. So let's put these asymptotes on the graph. X equals -4. That is over here. And y equals -7 is way down here. And then we're going to kind of look at our calculator to tell us where our lines go. So the lines are going to go here and here. And again, they don't have to be perfect. So that is all for this video. Go ahead and go finish numbers 5, 7, and 9 on your own. Remember, you were supposed to do the other ones earlier. So if you skipped that part, go back and do them. And you can use calculators to check your answer. Thanks for listening and have a great day.